Happy morning, students. So today we are going to start rotation plus translation. Very important topic as far as rotational motion is concerned. Okay, or you can say translation plus rotation. Translation plus rotation. Okay, what is translation plus rotation actually? If we take an example, suppose we are talking about a wheel. Okay, this is a wheel over here. And in this wheel, what is happening? This wheel is moving ahead. Okay, it's moving ahead. And at the same time, there is a rotation also. Okay, it's moving with v speed also, and there is a rotation also. This is called translation plus rotation. But in general, if you see, its motion is actually complex motion. If we talk about a particle, any particle's motion, suppose here's the particle I take, its motion is complex. Let's try and understand more. If suppose I take rod, this is a rod. Okay, this is moving in this direction, but at the same time, it's moving in having angular velocity also. Let's try and understand. I'll try to show you that this is kind of a rod, right? So what is happening with this one? This is moving ahead also. At the same time, this is moving like this as well. So how is the motion of this? If suppose any particle I take, the topmost point. Now how is its motion? Just try and see if suppose I can rotate it like this. Yeah. So see how it is. This topmost point's motion. Okay. My hand is moving ahead also, and this is moving in this. So quite a complex motion. Okay. If I say this point here, let's take it in the wheel. So what is happening? If I can make and show you what kind of motion it is. Okay, this is point A, let's say. Next time, what will happen? This has moved from here to here, but this A, let's say, is coming here. This A reached here because it's rotating. Okay, this is also rotating over here. Next time, when center is over here, let's say A point is here at the top. Then the next instant, maybe A is here, then again A is at the bottom. So how is the motion if I trade that, if I join these points, you see? What is this? Is it a known motion to us? Is it a parabola? No. This is cycloid. It's a complex motion. It's complex. Same way this rod I talk, this particle, if I throw it, okay, if I can show you here, if I can throw this one, okay. You see that how will be the motion of this tip of the marker, see. Again. Okay, so how was the motion? It was a complex motion, right? This marker is moving ahead also, and at the same time, this is moving in circular motion. So you have to combine both. That's what called translation plus rotation. So it's complex, but we can make it very easy. How to make it very easy? See then. If I say that we have to sit over here at the center, that means with respect to center of mass. If we are the reference and we are sitting over the center of mass, then with respect to center of mass, what kind of motion every particle is doing here? Circular motion. And I know everything about circular motion. I know because we have studied it. Straight line motion, we can talk about. Circular motion, we can talk about very well. So we don't have any problem as far as these two motions are concerned. Okay, so when we are going to sit over center of mass, then every particle on this wheel is doing what? Circular motion. That's the property of rigid body. We have studied that. Right. Here also, if I sit at the center of mass, then what this particle will do with respect to me? Circular motion. Right. So this is the way you need to study translation plus rotation. We have to split it into two parts. What are two parts? One, the motion of center of mass plus the motion of particle with respect to center of mass. This is how we have to break it. Okay. Is the thing clear to you? Even in projectile motion also I can show you the same thing. If suppose I am throwing my marker as a projectile, okay, I'll show you in this way. Okay, here Okay. Suppose this marker. Okay, I'm going to throw projectile's path. So what will happen? Center of mass will continue to move in a projectile path only. There is no doubt about that. Like this. This is center of mass. But if suppose that this was a marker, marker's length is this. This point is A and this point is B. This is the marker. And I twisted it like this also. Like this is V and then I made it like this also. Angular velocity omega. Then if suppose I want to know at this point, this particle A, how it is. Then he said, okay, after time t it has reached by A. So after time t it will move by omega t. What else? This position of this point I can find with the help of projectile motion. I know. Okay, u cos theta is horizontal speed, u sin theta is vertical speed after time t. Along horizontal its position will be u cos theta t. Along vertical it will be u sin theta t minus half gt square. We know that. But if we talk about point A, what point A is that? With respect to center of mass, it has rotated by omega t. Okay, so earlier it was horizontal. Now it has moved omega t. This is omega t. So point A is here. Now can I write its coordinates? Yes. That's very easy for me. I can write its coordinates. So what we are doing is we are making this complex motion easy. What are we doing? We are saying that okay, we are going to study it with respect to center of mass, motion of center of mass separately, and the individual particles motion. We are going to study with respect to center of mass. This is how translation plus rotation we are going to study. Okay, so far the thing is clear to you. Let me show you what are we going to do in this chapter. First we will try and learn how to write certain things in it. What certain things? That means we would like to know how to write distance, how to write displacement, how to write velocity, how to write speed, angular momentum, kinetic energy, everything we'll learn. And then we are going to use it. Okay? So, everything is clear so far? Okay. Right guys, so let's see. First of all, we are going to talk about displacement. Okay, we're going to talk about displacement. And let's say the most easiest type of the things that we are going to see is wheel. And mostly the questions will be asked from wheel. Okay, 85% of the time questions will be from wheel. 15% they will change it into rod. Both we are going to see, there is no problem. If you know wheel, how we can do with wheel, we can do with rod also. Okay, so let's see. We are going with the wheel. So displacement we want, right? So here this center, let's say its velocity is v, and this is moving with omega. Okay, if suppose I ask you the timing, I ask you, what will be its velocity? What will be its omega? Omega. Can we say omega is v by r over here? Can we say v is equal to, rather, omega is equal to v by r? Answer is no. That was the case when the wheel was doing pure rotatory motion with omega and radius was r. Then we said that this point's tangential velocity is r omega. That was tangential velocity. This v is not tangential. This is a translation speed or translation velocity of the center of mass. So here omega is not v by r. We are going to see one of the case in which we will be calling it as a rolling, in which v will be equal to r omega. That's a different thing altogether. But here omega is not equal to v by r. Is that clear? Okay. So in this case we have taken that center of mass is moving with velocity v and rotation for the circular motion, these particles where every point is doing about center of mass is having angular velocity omega. Okay, now let's say after time t this wheel is here. Okay, now what we want to see that how much is the displacement of this particle A. This particle A. Okay, so what has happened? This center, the center over here, this has moved how much? Say Vt, because its speed is given Vt to us. So in time t it has moved Vt. And what about a particle? A particle will move omega t. So from this position it must be somewhere here. So let's say it's here. So from this position, how much it has moved? It has moved omega t. Now question is, this is a particle, okay? Can you write the displacement of a particle? Answer is yes. Why not? Displacement will be, if suppose I say this is origin. This is origin. Then position of a particle is Vt minus this. What is this now? This is r, and this is r sine omega t. So x coordinate is Vt minus r sine omega t. This is x coordinate. Right, y coordinate. Now y coordinate means this. Now we all know that this is r cos omega t. So y coordinate is r into 1 minus cos omega t. Very simple. Displacement we are able to write. Right? No issues, no problem. Simple, right? So we are able to write displacement of any particle anywhere we can write that. There is no issues with that. Okay? Only thing is we know that the displacement when we are talking, then center of mass is moved by Vt, and with respect to center of mass, how much it has moved? Omega t. Right? This is displacement. Now let's talk about velocity then. Okay? Let's talk about velocity. Okay, so velocity, let's see. Now in velocity also, if I'm taking this wheel over here, okay, velocity of center of mass is v, and this is omega. Right, now what we want? We want to write velocity of any particle. Velocity of center of mass we are taking here constant, that is v. And omega is also constant. Right, we are not having any acceleration at the moment. When we talk about acceleration, we'll take it there. Okay, so velocity of center of mass is v, and velocity, angular velocity of this wheel with respect to center of mass is omega. Fine. Now choose any particle. Any particle we can choose in this one. Suppose particle is here. So velocity of particle with respect to center of mass, we write as what? Vp minus Vc. Yes or no? This is what we have studied. So velocity of particle, we can write what? Velocity of particle with respect to center of mass plus Vc. Right, now Vc we already know, that's V. And velocity of P with respect to C is what? R omega. So any velocity, any particle's velocity is going to be what? R omega plus V. R omega plus V. This is most important for us. Okay, now see, I am going to combine and I am going to show you that how is the velocity of each particle, what is the direction, everything we will see. Okay, so see then, this is clear, right? Okay. Okay, so see now, I am going to make both separately, one for translatory motion separately and one for rotatory motion separately. Okay, so first is, let's say, circular motion exclusively. In this one I am not putting up translatory motion at all. Okay, so every particle's motion, like this particle having velocity r omega, this particle here is having r omega, right? This particle having velocity r omega, and this particle here is having velocity r omega, and in between we can make whichever point here. Plus, now velocity of center of mass. Now velocity of center of mass means what? Velocity of center of mass means v. So that means this velocity we have to add for every particle. Yes, that's what we saw. Velocity of p is equal to velocity of particle with respect to center of mass, that is circular motion, plus velocity of center of mass. So every particle, v, this particle obviously v, topmost particle v, and this particle also. This plus this we have to do. What is the resultant? Resultant particle's velocity will be what? Let's see. Okay, the topmost point is this is V, this is R omega. Both are in the same direction, so I am adding it. This is V plus R omega. Right here, they are in opposite direction. R omega is this direction, V is this direction. So we don't know which one is greater, but yes, we can write it. If suppose I want it to go forward, then we can say it's V minus R omega. Okay, this point, V is in this direction, R omega is in this direction. V is here, R omega is here. Where will be resultant? Where will be resultant? Resultant is somewhere here. Right? Resultant somewhere there. And here means at this point, R omega is like this, V is like this. Where will be resultant? Resultant in the middle, somewhere. Right? And this is how we can find the velocity of each point. Okay. Now suppose it's rolling. We are going to see the rolling case. Rolling will be what? When V will be this V will be equal to R omega. Then what will be? This is V, this is also V, then this will come root 2V. If suppose this is equal to V, then this will come root 2V. This will come root 2V. This will come 0. This will come 2V. Right or not? Perfect. Now suppose in this case itself, if I ask you, what is the velocity of a particular point after time t? Like we found the displacement case. Here also I can ask you velocity after time t, right? So if I am asking how to find it. This is clear, right? Okay. Let's see then, how can we find velocity of any particle after time t? Now, in this one both the things are there. Velocity of the particle after time. So see, first of all let's decide which particle we are going to choose. Let's say this point A on its velocity after time t. So what we know, this particle may have reached at this point. Right? May have reached at this point. Now what it has? Velocity of center of mass in this direction V is there. Okay, and in this direction R omega is there. Correct? Now I can find very easily what is the velocity, but I need to find what is the angle between the two. If I know the angle between the two, I can easily find. So see then, now first A is here. First A is here. Now A's position is this. So how much it has turned? This was first position. Now this is the position. How much it has turned? This is turned omega t. Theta equal to omega t, right? It has turned by omega t. Okay, but what mainly I want? I want this angle. Why I want angle? Because the resultant velocity that I know is actually vector sum of these two. That is v square plus r omega whole square plus 2v r omega to the angle. Now what is this angle? Now see that. This is omega t, this is 90. This is 90 minus omega t. This is 90 minus omega t. And what is this? This is radius and this is tangent. This is 90. The total angle between r omega and t is 180 minus omega t. So v square plus r omega whole square plus 2v r omega cos 180 minus omega t. This is the magnitude of velocity, right? So what we are getting? This is v square plus r square omega square plus 2v r omega cos 180 minus omega t means second quadrant. It is second quadrant, cos theta is negative, so minus cos omega t. This is velocity's magnitude. If we know exactly how much is omega, we can find it easily what it is. Okay, t is given to us, we can find it easily. If suppose it's given to us that omega value is something, v is something, and t is something, can we find this magnitude? Obviously, yes. No doubt about that. No doubt about that, right or not? If suppose I can make one question out of that. Suppose I'm doing it for the rod. Okay, let's do it for the rod. Let's say our rod here is moving with 5 meters per second. Okay, and at the same time it's rotating with omega. Omega, let's say, is 5/6 radian per second. Okay, and this point's velocity I want. Point A. Find velocity of point A after 2 seconds. After 2 seconds. So what will happen in 2 seconds? Obviously this is moving ahead, but how much it will rotate in 2 seconds? Omega is 5/6. So rotation will be 5/6 into 2. 5/6 into 2 means 5/3. So this definitely has moved to this point, no doubt about that. Okay, it has moved 10 meters in 2 seconds, no doubt. But it has turned also. How much it has turned? It has become like this. How much it has turned? 5/6 into 2. That is 5/3. That means 60 degrees. Not like this. Little more. Become like this. Okay. This is 60 degrees. So your point A is here somewhere. Okay. Now its velocity is which direction? This is r omega. And this is v. Right? Now what this angle is then? What is this angle? That we need to find. Right? So this is vertical over here. Okay? Then this is 60, so this is 30 for sure. Then this is 60 degrees. Right? So angle between velocity, this is velocity v, and r omega is still 60 degrees. So can you find the resultant of the two? Yeah, why not? So we can write it over here. Resultant value will be v square plus, its formula is here actually, v square plus r omega whole square plus 2v r omega. But what is angle here? Cos 60. So cos 60 and this 2 is gone. Now values you can write. This is 5 square. Okay, length also I have to give you. Take length as 4 meter. So radius will become 2. So here 2 into omega means what? 5/6 square plus 5 into 2 into 5/6 square. So what it is? 25 plus this is 5/3 again. So 5 square by 9 plus 5/3 square root. Right, keep the pi value and we'll get the answer. So this way we can find velocity of any particle. Again, the clue is same. Velocity of center of mass plus velocity of any particle with respect to center of mass. Nothing else. Right? Okay, let's move further then. Let's talk about distance. Okay, displacement we saw, velocity we saw, distance. Now distance and displacement, what the difference is? Displacement is velocity into dt, or velocity integration of velocity with respect to time. That is displacement. Whereas distance is integration of speed into time. What is speed? Speed means magnitude of velocity. Speed means magnitude of velocity. Right? So distance. Distance is not same as displacement, first of all. Remember that always. So here, distance will be what? Magnitude of velocity into dt. You see that many questions we did in kinematics on this one. Distance, displacement. Okay? And same way, this is Vd. Magnitude of V. Now, magnitude of V we found. If suppose it's a wheels case, I just recollected what we have written a little while ago over here. Okay? It was something like V square plus R omega whole square plus 2v r omega minus cos omega t. This was the magnitude. Okay, this dt is basically the distance, and what I have written over here, magnitude of velocity, that is the speed. Okay, so this way we have to find the distance traveled, but distance traveled, remember, always is different than the displacement. Displacement we saw little while ago, we found the coordinates vt minus r sine omega t, x coordinate, r minus r cos omega t, y coordinate, and we know that how to find the displacement's magnitude. Okay, that's different. This is different. Okay, so this is the way in which you can find the distance, and this is what? This is speed. Okay, now we'll go for acceleration. Acceleration also we should see now. How to write acceleration. Okay, acceleration is very similar to what we have done in the case of velocity. Okay, so acceleration. Alright, so here it is. Suppose acceleration of center of mass is a, velocity is v, and it is accelerating with it. That means velocity keeps on increasing. At the same time, there is omega initially, and then acceleration is alpha. Okay, I'm not doing anything, I'm just making it same way as we did in the case of velocity. Okay, so every point's velocity I'm directly making here. I'm not making three wheels separately, I'm directly adding it to this one. Okay, so this point here, if we consider acceleration is like this and angular acceleration is like this, then this point's acceleration A is in this direction, r alpha downwards. Resultant will be, we know that. At the topmost point, A plus r alpha. The bottommost point here, A minus r alpha. Okay, and here A is here in this direction, r alpha is here. Okay, the resultant is this. Right, here also r alpha will show like this and A like this. Whereas here both are in the same direction. Right, exactly same like how it was V plus r omega, V minus r omega, and then, okay. So in this one, but there is one more thing that I want to show. When we talk about circular motion as such, in circular motion we used to have two accelerations. One was radial acceleration and one was centripetal acceleration. In this one, with respect to center of mass, it's in circular motion. So when both accelerations will be there or one only? Both will be there. Both we have to show. Not only tangential as r alpha, but at the same time you have radial acceleration also. So then what I have to do? I have to make that also, obviously. In this direction your radial acceleration is also there. So you don't show this right now, okay? This is A, with that one radial acceleration is also there. Here also there is radial acceleration like this, and here also there is radial acceleration like this. Everywhere radial acceleration is there, which is acting towards center. Okay, so if I have to write that acceleration of any particle with respect to center of mass, it is basically AP minus AC. Perfect, no doubt about that. The acceleration of any particle is equal to what? Acceleration of particle with respect to center of mass plus acceleration of center of mass. Acceleration of particle plus center of mass, it is actually A tangential plus A radial plus acceleration of center of mass. Are you able to understand? Acceleration is like this. Okay, is that clear? So this way we can write acceleration. Okay, one question will be there, one standard question we'll do. Okay, The standard question is related to the distance traveled by any particle in translation plus rotation. That's actually a question of rolling, okay? But since its value is such that we should know it, okay? So we will know. We'll do it first, find the answer, and then we'll remember that. What is that? What is the question? Question is, this is a V, right? This is moving in this direction with V, and at the same time, its angular velocity is omega. Now this particle here, how much is this particle moving in one rotation of the V? That is the question. In one rotation, how much it will? One rotation means is, if I can say, the next instant, particle A is here, then after that, particle A is here, then after that, particle A will be here, and then finally, particle A will be reaching here. This is one rotation. So we saw that its path is something like this, right? And which is cycloid, we say. So we have to find how much distance it has traveled. That means the length of the path. That is only the distance. How to find? How to find? The distance, as I told you, basically is what? Magnitude of velocity, right? D. Simple, nothing is there. V also we know, as a function of time we already have calculated V, so directly we can write over here. What it was? Root over V square plus R omega whole square plus 2V R omega and minus cos omega. Directly I am taking from what we did already, right? Okay. Now, from here I can move only if suppose we have a relation between V and R omega. If we don't have a relation, we cannot move ahead. Suppose it's a pure rolling case. That's one of the cases. Okay, we'll see it later on. Pure rolling. What is pure rolling means? V equal to R omega. Okay, just a minute. Okay, so if we take the case of pure rolling in which V is equal to R omega, and I am going to keep here in place of R omega V. So this is V square, this is also V square plus 2V into V, so minus cos omega t. Okay? Now what I can do, this is also 2V square, 2V square to 1 minus cos omega. Right? 1 minus cos omega t. Cos omega t I can write as what? 1 minus 2 sin square omega t. So that means this entire thing is 2 sin square omega t, right? So 2v square into 2 sin square omega t by 2. Have I written correct? Okay. So what we are getting? 2v sin omega t by 2. Correct? 2v sin omega t by 2 and 2 cancel, right? Can I cancel 2 and 2? Yes or no? No, we can't cancel that, right? Because this is half of the angle. Okay, so this is the magnitude, this is the just magnitude of velocity, okay? dt is still there. Right? dt is still there. So here also dt is there. Now we have to integrate that. So 2v is outside. Okay? 2v is out of this. Okay. Fine. So 2v is outside. Now we have sin omega t by 2 dt. Now from where to where we are integrating? We are integrating for time. One rotation means, one complete rotation means 0 to 2 pi by omega. This is the time period, am I correct? So integration of this will come what? What is the integration of sine omega t by 2 dt? Its integration will come. Sine's integration is minus cos, right? Minus cos omega t by 2 by into 2 by omega, if I am correct. We will check it, okay? We will check this one. How to do this? Even I forgot it, right? Okay. Anything is there like sine omega t dt. Now, how to integrate that? If you remember that, I used to say that take omega t as something. Let's say omega t is x. So I have converted this into x, but still dt is there. So differentiate this then. Okay, with respect to t. So omega equal to dx by dt. So what is dt value? Dx by omega. Put it here. This is sine x, omega outside into dx. Its integration minus cos x. And omega is here outside. X is what? Omega t. So minus cos omega t by omega. So whatever is here as a multiple or coefficient of t, it comes in denominator. Right? So here also you see sine omega t by 2, this is minus cos omega t by 2. Whatever is in coefficient of t, that will come in denominator. That means denominator will be what? Omega by 2. It will become 2 by omega. Is that okay? This is substitution method we learned in the beginning. Okay? So, we have integrated this. This is what we got as integration. And here the limits are what? 0 to 2 pi by omega. So this constant you take out first. 2b, 2 by omega. Okay. Now, first this minus also you take out. Now cos omega by 2 into 2 pi by omega minus cos 0. So omega cancel, 2 cancel. Cos pi minus 1. So minus 1 minus cos 0, 1. And what we have here? Minus 4v by omega. Okay. So minus 4v by omega here is. So minus plus 8v by omega is coming. But we already have taken v equal to r omega. Put here r omega by omega. So the distance that particle is traveling is how much in this pure translation, pure rolling case, in which Vk equal to r omega is 8r. The total distance traveled by the particle is 8r. Okay, so that's all for today. Okay, just learn how to write all these things. In the next class, we are going to see momentum, angular momentum, and other things. And after that, this thing will become very easy for us. Okay? Alright, guys. Bye for now.